Okay, so we've got this question here. It says angle alpha is acute and cos alpha is 3/5. Angle beta is obtuse and sine beta is 1/2. It says find the value of tan alpha as a fraction for part A. So we know that we need tan alpha. We know from our trig identities that tan alpha is just sine alpha over cos alpha, isn't it? So since they've given us cos alpha, we just need to figure out what sine alpha is and plug this in. So we can say so far it's going to be sine alpha divided by 3/5, isn't it? Because that's what cos alpha is. Now it tells us that angle alpha is acute. So all you have to do here is if you get a cast diagram, just to remind yourself of the quadrants and where the trig ratios are positive, right? Remember, we know that in the first quadrant, sorry, all of the trig ratios are positive. In this one here, only sine. In this one, only tan. In this one, only cos. So since they told us that angle alpha is acute, well, that means that it's going to be in this quadrant here. So that means we'll be using the positive value of sine alpha, sorry, right? So we know that cos alpha is equal to 3/5. If I square both sides, this gives me that cos squared alpha is 9/25. And now remember, we know that from our trig identities, sine squared alpha is 1 minus cos squared alpha. So let me just make it a little bit more room. And then we have that here. So we can say sine squared alpha is equal to 1 minus 9/25. And this is just the same as 16/25, isn't it? So we can say that sine squared alpha is equal to 16/25. So that means that sine alpha is equal to the square root of that, which is going to be plus or minus 4/5. Now, since alpha is acute, we know that we're in the first quadrant where sine is positive. So we have to pick the positive solution here. So we can say that sine alpha is just 4/5. And then we can plug this in there. So that's fine. So let's do this here. This will give us 4/5 divided by 3/5. And this is just the same as doing 4/5 times by 5/3. Fives cancel. We know that tan alpha is now 4/3. So that's part A, first question done. Now we've got this one here. Tan beta, we need to find in third form. And they've told us that angle beta is obtuse, right? So, and they told us that tan beta is 1/2. So again, if angle beta is obtuse, then we know that means it's between pi/2 and pi, or 90 and 180. So it's going to be around here. So the angle beta is going to be something like this here. And we know that sine beta is 1/2. And remember, again, tan beta is sine over cos. So we can say here, tan beta is equal to sine beta over cos beta. And we know that sine beta is 1/2. So we just need to figure out what cos beta is, and we're done. So now we can say, okay, fine. If we use our trig identities again, we can say, well, fine. Since we know that sine beta is equal to 1/2, if I square both sides, we can say, fine. Sine squared beta is equal to 1/4. And remember, we know that cos squared beta from our trig identities is 1 minus sine squared beta. So therefore, we can say that cos squared beta is just equal to 1 minus 1/4. Oops, I need a quarter there. So therefore, cos squared beta is equal to 3/4, isn't it? And then that must mean that cos beta is equal to the square root of that. So remember, we just square root the top and the bottom. So square root of 3 is 3, square root of 4 is 2. And then obviously we need a plus or minus, don't we? So we've got this here. Cos beta is equal to plus or minus √3/2. Now, since beta is obtuse, we know that it lies in the second quadrant, and we know that cosine is negative there, right? Because only sine is positive. So that means we have to choose the negative solution. So we can say cos beta is equal to minus √3/2. Now, if we go back here, remember we had the top already. So I've got 1/2, and I'm going to divide this by cos beta, which we know is minus √3/2. Put this here. And then now, same thing as before, 1/2 times by 2 over negative here, √3. The 2's cancel, so this is just 1/√3, isn't it, with a negative sign. So this is tan beta here. Perfect. So now we've got our value for tan beta. It's minus 1/√3. So fine, we've done part A. Now part B says, hence show that tan alpha plus beta is equal to m root 3 minus n divided by n root 3 plus n, where m and n are integers. So again, we need another trig identity, don't we? So let me just get this here. Let me just crop this so we can see this. So this is a question. Now remember your addition formula for trig, for tan. Tan alpha plus beta is equal to tan alpha plus tan beta divided by 1 minus tan alpha tan beta. So all I would need to do for this one is just plug in my values of tan alpha and tan beta. And we know that tan alpha is, let me just remind myself, tan alpha was equal to 4/3. So I've got this here. And tan beta is equal to negative 1 over root 3. Yeah, negative 1 over root 3. So that's fine. We've got this here. Now all we're going to do is just plug all of these in. So putting this in, we've got tan alpha is 4/3, and then plus that there, which is minus 1 over root 3, and then over 1 minus tan alpha, which is 4/3, put this in a bracket, and then minus 1 over root 3. And we need it in this format here. So let's just tidy this up first and see what we get. This on the top becomes 4 over 3, sorry, minus 1 over root 3. Let's put this down here. Divided by, and then we've got 1, we've got 2 negatives, so it's going to be 1 plus 4 on the top and then 3 root 3 on the bottom, isn't it? Okay, so we've got that. Now we need it in this format where we have a constant times root 3, right? So for me, when I look at this, I can see in my current form, I've got fractions all over the place, right? And we don't have that there. So what I could do is say, okay, well, fine. If I look at all of these here, to get rid of all of these fractions, I can just multiply. I'm going to write it in a different color. I'm going to multiply top and bottom by these denominators here. So I'm going to multiply the top by 3 root 3, and I'm going to multiply the bottom by 3 root 3. Right? So if I do this here, what will this give me? Let's see. Equals here. So I put this in a bracket like this, so it's a bit clear. If I do 3 root 3 times this 4/3, right? The 3's will cancel, and I'll just be left with 4 root 3 right here. And then minus, and then what will happen here? The root 3's will cancel, just leave with the 3 on the top, so it'll be minus 3. And then on the bottom, 3 root 3 times 1 is just a 3 root 3. And then we've got 3 root 3 times this one, they will cancel, just be left with plus 4. So the final answer is 4 root 3 minus 3 over 3 root 3 plus 4. You can see it's in the exact same format that they wanted it in. So we're done.